Friends, today we're going to talk about proving triangles similar. In our last section, in order to prove a triangle similar, we had to show that all three angles of one triangle were congruent to all three angles of another triangle, and that the corresponding sides of both triangles were proportional. So they want us to say if these two triangles are similar. Well, we know that angle A is congruent to angle D. We know angle C is congruent to angle F. And if we found the measures of angle B and angle E, remember the triangle needs to add to 180. These would both be 80 degrees. So angle B is congruent to angle E. And then if we look at the corresponding sides, we would do AB divided by DE. We would do BC divided by EF. And we would do AC divided by DF. So if we look at those side lengths there, 32 over 40, which equals 0.8. 24 over 30, which equals 0.8, and 36 over 45, which equals 0.8. So yes, these two triangles are similar because all of the angles of one are congruent to all of the angles of the other, and also the sides are all proportional. So now the question is, would any triangle with two angles measuring 40 and 60 be similar to ABC? Yes, they would, because they would all be 40 degrees, 60 degrees, and 80-degree triangles. Our first theorem is the angle-angle similarity theorem. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So all we have to show is two angles of one congruent to two angles of another. Triangle ABC has angles whose measures are 61 and 60. It doesn't tell us which ones. We're just going to call these 61 and 60, which means angle B would have to be 59, because they have to add to 180. And the other ones are 65 and 60, which means angle E would have to be 55 degrees. So if we notice here, I only have one pair of congruent angles. So no, because we only have one pair of congruent angles. Here they're telling me that angle A and angle R are the same, and they're telling me angle B and angle S are the same. We can tell by looking at the markings, which then would have to mean that angle C and angle T are the same. So we have two angles of one triangle congruent to two angles of the other triangle. So the triangles are similar by the angle-angle similarity theorem. Here we have A congruent to R and C congruent to T. So again, we have two angles of one triangle congruent to two angles of the other triangle. So then we can say triangle ABC is similar to triangle RST by angle-angle similarity. Notice how I wrote them. A and R are the same, so they both had to come first. C and T are the same, so they also had to be in the same position, which means B and S are also in the same position. The first triangle has angles that are 59 degrees and 62 degrees, which means the last angle would have to be 59 degrees. And then the other triangle has angles that are 65 and 62, which means the last angle is 53. So no, they are not similar because there's only one pair of congruent angles. Again, the only pair of congruent angles I have there is the 62 degrees. All right, here they're telling me that all of the sides are proportional. So is there a similarity transformation that could map PQR to LMN? Well, I can see that it's dilated because it's smaller and it's been rotated and it's been reflected. So yes, a dilation, a rotation, and a reflection would map PQR onto LMN. This is the side similarity theorem. If the corresponding sides of two triangles are proportional, then the triangles are similar. So if we divide corresponding sides and get the same thing every time, we can say that the triangles are similar. So if we look here, A is 3, B is 4, C is 6, D is 9, E is 12, F is 18. If we look at our corresponding sides here, AB divided by DE, BC divided by EF, and AC divided by DF. A and D both come first. And then B and C both come, B and E both come second. And C and F both come third. So it matters how we write it. So plugging in what we know here, A over B, or AB over DE is 3 over 18. Not 3 over 18, 6 over 18, which is 1/3. BC is 3, EF is 9, which is 1/3. AC is 4, DF is 12, which is 1/3. So we have 3 pairs of proportional sides here. So yes, they are congruent by the side similarity theorem. Let's look at these ones. Pay attention to how it's written. BA comes first, FD comes first. So those are a pair of corresponding sides. AC comes second and third. DE comes second and third. So those are corresponding sides. BC comes first and last. FE comes first and last, which means those are a pair of proportional sides. So plugging in what we know here, we would have 10 over 25. We would have 21 over 35. And we would have 15 over 20. And each of those simplifies to 3, but not all of them. That's not true. This simplifies to 2 over 5. This simplifies to 3 over 5. And this simplifies to 3 over 4. So these are not proportional because they're not all the same thing. So no, those are not similar because we do not have 3 pairs of proportional sides. All of these would have to give us the same answer in order to say that they're similar. Let's look at this one. AB over DE, BC over EF, and AC over DF. So we have 8 over 4, which is 2, 10 over 5, which is 2, and 12 over 6, which is 2. So since they all simplify to 2, we can say yes, these are similar by the side similarity theorem. The last one then is side angle side. If an angle of one triangle is congruent to an angle of a second triangle, so in this case, B and E, and the sides that include the two angles are proportional, then the triangles are similar. So if the two sides that make up the angle are proportional, the angle has to be in between those two sides. Then we can say the triangles are similar. So let's look at this one. We know these two angles are congruent because those are vertical angles. And then if we look at the corresponding sides here, 27 over 18, which gives me 3 over 2, and 36 over 24, which gives me 3 over 2. So I have a pair of congruent angles, and then my corresponding sides are proportional. So yes, we can say that triangle ABE is similar to triangle DBC by the side angle side similarity theorem. So got a couple more here. I know that angle B is congruent to angle F. So I have my angle. Let's look at the sides. If I look at the smaller side on my first triangle, that's 12. The smaller side on my second triangle is 8. So those two are corresponding. And that gives me 3 over 2. The bigger side on my first triangle is 24. Bigger side on my second triangle is 16. That also simplifies to 3 over 2. So now I can say that these two triangles are similar. I got to be careful the way I write it. I'm going to start with B because that's the angle that I know. I'm going to go from B to A to C. So I started at my angle and went toward the small side. I'm going to have to do the same thing here. Start at my angle and go toward the small side. So similar to triangle FDE. All right, one more example here. I know angle B is congruent to angle P. If I look at the smaller sides, that would be AB and PQ. So 3 over 6, which is 1/2. The bigger sides then would be BC over PR, which is 3.5 over 7, which is also 1/2. So I have a pair of congruent angles and 2 pairs of proportional sides. That's enough to say, yes, triangle, the way I write it matters. I'm going to start with the angle that's congruent and go toward the small side. Same thing here. Start with the angle I know is congruent and go toward the small side. So triangle BAC, similar to triangle PQR by SAS, side angle side similarity theorem.